This lesson is going to be the first of several lessons that deal with these things called congruent triangles. Now, we've already discussed congruency before. So, like if I made a line segment right here and I said, okay, this line segment is going to be congruent to another line segment. So watch what I'm going to do. I'm going to copy and I'm going to paste. And I'm going to put another one right there. Now this, I copied and pasted. So this is going to be the exact same size, length as this thing right here. It doesn't matter how I move it around. It's still, I didn't change the length of it at all. Let's see if I can grab it. Oh, come on. And maybe, there we go. All right, I could change the length of it. I could, if I wanted to, twist it around. All right, did that make this line segment any different length than the original line segment? No. So if these two line segments are equal to each other in length, we can put a little tick mark here, a little tick mark here. That means these two line segments are congruent. So if I call this line segment AB and I call this line segment CD, I could say that line segment AB, or the length of, I'm not going to put the line segment over top of it, the length of line segment AB is congruent to the length of line segment CD. Again, if I don't put any line segment over top of it, it's talking about the measurement of it, the length, how long the line segment is. So the length of line segment AB is congruent to the length of line segment CD. Now in these situations, I don't really care that much if you put congruent or not, but today we're going to introduce things that are congruent triangles. So what does that mean? What does it mean to have a triangle that's congruent? I understand what it means for a line segment to be congruent, but what about a triangle? Well, before we talk about triangles, let's talk about just basic polygons, okay? Let's just talk about a congruent polygon. So I've got a crazy, oops, before I started teaching the lesson, I copied. Hold on just a sec. Okay, here we go. This is what I wanted. Sorry about that. I've got a polygon. 1, 2, 3, 4, 5, 6. So it's a hexagon. And it's not a regular hexagon or anything. It's just a regular old polygon. And what I can show you is if I copy and I paste, just like I did the line segment, I have two exact shapes right here. They're exactly the same shape. They're going to be the same angles. They're going to be the same lengths of the sides. Everything is going to be the same on this. So we would say that these would be congruent to each other. Equal sign with a little squiggle on the top. This polygon is congruent to this polygon. And you know they are because I copied and pasted. So if they are congruent to each other, what do you think we could say about some of the sides? For instance, this side and this side, they're exactly the same. In fact, watch this. If I took this, picked it up, and put it right on top, check it out. It fits exactly, doesn't it? All right, so that shows if it fits exactly on top of the other, then that means that they are congruent to each other. So let's continue with this. So I've got this side equal. That means these two sides would equal. That means these, well, there's going to be a lot of tick marks. This is 4. That's 4. That's 5. Okay, and 2, 3, 4, 5, and 6. We don't usually do this. 3, 1, 2, 3, 6, and there's 6, 2, 3, 4, 5, 6. Okay, so if I showed you that all the sides are equal to each other, and what else might be true about this? Well, the angles must be the same, right? If I took this and I picked it up, put it right on top of here, this angle and this angle are exactly the same. So those are equal. These two right here are equal to each other because they match up to each other. And I don't think I'm going to finish doing this. You get the idea, okay? I'm not going to do 4, 5, and 6 arcs. That would be way too messy. But you get the idea. All the parts that match up, what I want you to understand is if I took this and I lifted it, right, and I put it over here, it would line up perfectly with the other one. That means they are congruent to each other. We say that the parts that are equal, like this right here and this right here, we call these corresponding parts. It's a little different from the corresponding angles that we talked about in another chapter when we had two parallel lines cut by a transversal, but it's kind of the same. The word corresponding basically means they match up with each other. So if I pick this up, put it right on top of this, the sides that match up with each other are called corresponding sides. So I've got corresponding sides, and I also have corresponding, I'll write it down again, I also have corresponding, what do you think? I got sides and what else? Yep, I got angles. Corresponding sides and corresponding angles. So again, if I pick this up for about the 5th time now, if I pick this up, put it on top of here, the angles would match up, these 2 angles would match up, these 2, and so on. All 6 of them would match up. The matching up means that they're corresponding angles. Now, if I was going to put this into one big category, I would say these are all corresponding, I'll just shorten corresponding this time, corresponding parts. We're going to talk about this quite a bit in another chapter. I'm just kind of introducing this to you right now. Corresponding parts. So the sides and the angles of these polygons are corresponding parts. Well, you say the title of this lesson is Corresponding Triangles. Why in the world are you messing with this? Basically just to show you that you can also have other polygons that are congruent to each other, not necessarily just triangles, but triangles are pretty important. We're going to talk a lot about triangles here in a second. So let me give you another example, or we'll write something down here, but we're not going to use a hexagon. We actually will go to a triangle this time. Okay, here's a triangle, and what I'm going to do is I'm just going to label this triangle. Let's just call it ABC, make it real easy. And what I'm going to do is I'm going to copy and paste this triangle. Copy and paste. And we'll put it right here. And I'm going to label that as well. And we'll label it, I don't know, DEF. We won't get real fancy with our lettering here. So we'll just call it DEF. So if you take a look at these, now I copied and pasted, so you know that these triangles are congruent to each other. So what I could do is I could mark them. I could say that this side has 1 tick mark, and this side. See, since they match up, if I pick this up, put it right on top of that, they would match up. They're corresponding. They correspond to each other. Since I copied and pasted, I know that those 2 sides are equal. And same thing with these 2 sides, and same thing with these 2 sides right here. I also know that the corresponding angles are equal as well. So let's say if I put them on top of each other, this angle would match up with this one, so these 2 angles are equal. These 2 angles right here are equal to each other. And then you've got these 2 up here in this corner. And that's pretty easy to see. What if, though, now I'm going to do something here. We might have to look at the screen a little bit sideways because I'm going to twist some things around. Watch this. I'm going to put a little dot right there. Watch what I'm going to do. I'm going to kind of do this. Let's make it about like that. All right. And let's move it down a little bit. Now, I didn't really change the size of it. All I did was just twist it around, okay, as you notice. I didn't make it smaller. I didn't make it bigger. I didn't change the angles. I didn't change the lengths of the sides. All I did was twist it around. But they're still congruent triangles and how do you know which sides correspond to which? Well, because the ones that are already marked. So angle A down here would equal what? Angle D. And then angle C with 2 arcs would equal angle F, and angle B with 3 arcs would equal or be congruent to angle E. So just because I twisted it around didn't really make any difference as far as them being congruent to each other. Now sometimes though, when they'll take a triangle, they'll twist it, they'll flip it, they'll do all kinds of things, and it's kind of hard to tell which ones match up with each other. If I didn't have those little tick marks, I really wouldn't know which ones matched up. So what we do is this. This is really, really important because we're going to do this a lot when we deal with congruent triangles. We need to label these 2 triangles, and it's very important how we label them. So let's take a look. I'll call this one triangle ABC. Okay, I can call my first one anything that I want. So I'll just call it ABC. Well, I can use these 3 letters. Okay, I can arrange these 3 letters any way that I want. So I'm going to call it triangle ABC. Now, if I say that it's congruent to this triangle right here, I can't just put these letters in any order that I want. The letters have to match up with the corresponding angles up here in this triangle. So if I called this A, B, and C, what would I have to call this one? I can't just call it anything. If I decided to call this ABC, I have to put this in the same order. I have to put the vertices or the angles in the right corresponding order. So that would be triangle. Now, which one matches up with A down here? Well, that's got 1 arc, so D matches up, so that has to be first. B has 3 arcs to it. Which one down here has 3 arcs? This one right here, which is E. So I'll put an E here. And then C, which one matches up with C? C is the one with 2 arcs. F is the one with 2 arcs, so F would go together. So the A and the D go together, the B and the E and the C and the F. It has to be like that. Okay, you have to put these in that correct order. Now, remember what I said about ABC? I said the first one I could put in any order that I want. So let's rearrange ABC. I could call it, let's call it ACB. So I'm allowed to do that as long as I make sure that the corresponding parts match up with each other on the other triangle. So this is my triangle symbol. So if I called this ACB, look, we went ACB. I went 1 arc, 2 arcs, 3 arcs. I'm going to have to do it in the same order over here. So I'm going to go 1 arc, 2 arcs, 3 arcs. That would be DFE. DFE. Let's rearrange it one more time. There's actually 6 different ways I think you could arrange them, but I'm just going to do it like this. Let's start with B. Let's call it B AC. All right, so what did I do? I went B, AC. I went from 3 arcs to 1 arc to 2 arcs. Let's do the same thing down here with this triangle. Again, I went 3, 1, 2. So I'm going to have to go 3, 1, 2 down here. So I'm going to have to call it EDF. Notice every single time, which one does the A match up with? It matches up with the D. All right, it was first in both of those, but on this one it was the middle one. But A and D still match up with each other. Hope that makes a little bit of sense. So you have to write it in that order, or that's not the correct way to write it. So you can pick one of them. You can put it in any order that you want, but the second one has to match up. It's got to be corresponding to the first one. And that way you can tell which angles are equal to each other. Like if I didn't have any of that stuff marked, watch this. Let's get rid of all this, all the sides. All right, and sorry, it takes a little long to do this. Let's get rid of that, get rid of that, and get rid of that. Let's do the same thing down. Oopsie daisy. I grouped it together. I got to ungroup it. Let's try it now. Oops, it's still grouped together. What do I do? Group. There we go. All right, so let's get rid of that, get rid of that. Get rid of all this stuff right here. Get rid of that. Sorry, I guess I could have just paused it while I did all that stuff. Now let's take a look. What if nothing was marked here, but they told you that this was true? They told you that triangle ABC is congruent to triangle DEF. All right, and they didn't tell you any of this other stuff. That's all they told you. Okay, they didn't mark anything at all, did they? They didn't mark anything, but you should, from this information right here, I think, what do they call that? They call that, I don't know, there's some word for it. A congruent statement. That's what they call this. They call this the congruence. Sorry for my handwriting there. Congruence statement. All right, so the congruent statement is very valuable. Some people just blow it off, but it's really, really important because it tells you what angles are equal to each other and what line segments are equal to each other. And that's going to be super important, what we're going to do a little bit later. So if you take a look at this, how do I know what's equal to what down here? Okay, if I took this and I flipped it all around some more, how do I know which ones match up? Because some of the angles kind of look the same, like A and B, pretty close to the same. How do I know which one goes with A and which one goes with B? I look at the congruent statement. The A and the D go together, okay, the B and the E go together, and the C and the F go together. So from this statement, if I didn't have anything marked to begin with, I could say that angle A equals angle D. And I could also say that angle B and E are equal. So I could put a couple arcs here and a couple arcs here. And then I could also say that C and F were equal. All right, so I could say that that angle equals that angle right there. And you could also say the same thing with the line segments. Let's take a look at the line segments. From this congruent statement, you can see which line segments are equal to each other. Like for instance, the first two, AB, that's this one right here. How do I know which one is equal to AB down here? Well, I could look at this. These first two and these first two are exactly the same. So AB and DE are equal to each other. So AB and DE, I can put a little tick mark here. All right. Hope you're following what's going on because this is really, really important stuff. BC and EF, we'll do the last two. BC and EF must go together. So BC is this one and EF is this one right here. So they've got to go together. And then the other ones. What's the other one? I did the first two, the last two. What about the first and the last? So AC and DF have to go together. So AC has to equal DF. Okay, they are the corresponding sides. The green ones are the corresponding angles. Totally, it's corresponding parts. So that means these two triangles are congruent. So if they tell you they're congruent, that's the stuff that you can write down. This is really going to come in handy, I promise you, especially a little bit later on. But even in this lesson as well. Okay, so I hope that makes a little bit of sense. Let's press on. Let's do an example, I think. All right, here's your example. This is what they're going to ask you to do. They tell you some stuff up here. This is really important that you read the instructions, and they give you some basic information. They tell you that triangle ABC, this one right here, is congruent to triangle DFE. Now, those letters are in order for a particular reason. Remember, the A and the D match up with each other. The B and the F match up with each other. Notice we're in a little different order than what we did in the other problem. And then C and E match up with each other. You know what I would do right off the bat? I would actually mark those in your triangles so you know exactly what angles are equal and what sides are equal. So let's do that. A and D are equal to each other. So I'm going to put one arc here, and I'm going to put one arc right there. What else is true? B and F. So let's mark that. So this 99 is equal to angle F, which is this 8y minus 5. We'll put two arcs on it like that. All right, and then you know the third ones are going to be equal as well. Okay, so that would be C and E. There's C and there's E, so those would be equal to each other. It also tells you something about the sides. Now look at the only side with a Y and an X in it. It would be this one right here. That would be FE. So let's find out which one up here matches up with FE or corresponds to FE. Well, look at it. There's FE. Which one over here is the same place as FE? Well, BC is. So BC, this side right here. And how should I do that? Let's just circle it. Okay, so this side right here, or you know what we can do? Let's put a tick mark. All right, we'll just put one tick mark here and one tick mark right there. That means those two sides are equal to each other. Again, if you just tried to guess, because look, this side right here and this side right here kind of look about the same length. So it would be hard to tell which one of those exactly was equal. Is this side 2y plus x equal to 54, or is it equal to 38.4? It's hard to tell just by looking at the pictures. Sometimes they don't draw them very accurately. It's not drawn to scale, so you got to go by your information that they give you. It's very important that you do that. So we can go ahead and start trying to solve for some stuff. Let's do this. It's probably not the best way to start going 2y plus x equals 38.4 because we have two variables right here, and that'd be kind of difficult to solve for. It would be impossible, to tell you the truth, with just that one equation. So let's solve for something that we can find right away, and that would be this y, 8y minus 5. So that's what we're going to use. We're going to say 8y minus 5 is equal to what? Well, that has two arcs. This has two arcs. So 8y minus 5 is equal to 99. And that is really what you're trying to accomplish here. So the whole idea about what's equal to what, okay, was shown through this congruent statement. Then I can set this equal to this, and then I can solve for y. So we'll add a 5 to both sides. And 8y is 104. Divide both sides by 8. And let's see what we get for y. I'm actually using my phone for a calculator. So it's 104 divided by 8. And that is, I didn't do that right, I'll tell you that much. 104, try it again, divided by 8. There we go. And it's perfect. 13. It comes out exactly 13. Well, that was nice. So what we can do over here is this. Since I know what y is equal to, I can plug in that y right here because it's the same y. So what's 2 times 13? Well, that would be 26. And then plus x. Now what I can do is now I can take this and set it equal to its corresponding side. So let's do that, and then we'll do some algebra and figure out what that is. I got some space up here. Let's do it here. 26 plus x equals 38.4. Subtract 26 from both sides, so minus 26.0. Guess you don't really need that. But let's see what we get. We get a 4, we get a 2, we get a decimal right there, and then we get a 1. So it's 12.4. So x equals 12.4, and that's our answer for x and y. That's how we can use congruent triangles to solve for x and y. All right, here's a situation, and we call this the third angle theorem. Third angle theorem. All right, let's take a look. If you remember, I guess it was the last lesson. I can't remember exactly which one it was, but we talked about the angles of a triangle adding up to 180 degrees. Yeah, it was the last lesson. That's going to come into play right here. So look what I've done. I've marked these angles, and let's call this A, B, C, and let's call it D, E, and F again. Sorry for not being more creative with my letters, but it works. So I'm given this. I'm given that angle B equals angle E. I'm given that angle C equals angle F. The third angle theorem is talking about this missing angle right here. What about this angle? Can you say anything about this angle and this angle right here? Well, you actually can, because watch, if I added these two angles together, all right, let's just call this angle 1 and angle 2, just to make this easy, all right? And if this one arc has 1, that must be angle 1 as well, all right, because they're shown to be equal to each other. This 2 arc that's got 2, and we'll call that angle 2. So angle 1s are equal to each other, and the angle 2s are equal to each other. So what must be true about, let's call it angle 3? I guess we could have used the letters, couldn't we? A, B, C, that's why I put them there. But anyway, let's just use these right now. So angle 1 is equal, angle 2 is equal. What must be true about angle 3? Well, remember, all of these add up to 180, don't they? So watch, angle 1 plus angle 2, should say this, plus angle 3 equals 180 degrees on this triangle right here. Well, what about this triangle? The same exact thing is true. Angle 1 plus angle 2 plus angle 3 is also equal to 180 degrees. Now look, what's true about the angle, let's see. Actually, we don't even need, let's see how I want to do this. Okay, I've had a second to think about it. I'm going to change my approach with this. Sorry about that. I should have done this in the first spot. And you'll notice when I do these videos, I'll change my mind. I'll make little mistakes and that kind of stuff. But we all do, don't we? So remember what I said? I should have just used those letters, and that's exactly what I'm going to do right now. I think it'll make more sense to you. Let's do this. Angle A plus angle B plus angle C equals 180 degrees. Let's do this right here. So angle D plus angle E, let's make my angle symbol a little bit better, angle E plus angle F, that also equals 180 degrees, because when I add up all three angles, it equals 180, same thing here. Now watch, both of these equal 180, so if this is equal to 180, and all this stuff is equal to 180, that must mean that these two things, right, the whole entire thing, must equal each other. So let's write it like that. So let's go angle A plus angle B plus angle C must equal this stuff down here, because they're both equal to 180. So it must equal angle D. Man, my angle symbols are getting really bad. Angle D plus angle E plus angle F. All right, so since they're both equal to 180, they must both equal each other. But now, so we know that this is true right here. I hope that makes sense. We've kind of done that before, if you remember in that last lesson. Well, yeah, was it? It was chapter 3, it was 3.6, okay? It was the last lesson of chapter 3. Where we kind of did this, where we set them equal to y, right? They're both equal to y, so we set them equal to each other. It's the same idea. Now, check this out. Remember, what is true about the angle B and E? They're equal to each other. So watch what I can do. Since B and E are exactly the same, what I can do is I could subtract them from both sides, because they're exactly the same, right? So I can subtract them from both sides and they cancel out. What else is equal? Well, C and F are equal. So watch, angle C will cancel out with angle F. So what are you left with? You're left with angle A equaling angle D. And you probably figured that was going to be true anyway, but that's the reason, okay? It's kind of like a proof. It really is. We kind of proved that that was true. All right, so that means angle A must equal angle D. If you think about it, it kind of makes sense because I'm taking these two away from 180 to get to this. I'm taking the same exact two things away from 180 to get to this. So these two must be exactly the same. So if these were actual numbers, right, you would know that A and D were equal to each other. So if you had actual angle numbers in here, which I could have done as well, but you take them away from 180 and that's what's left over. All right. So this is called the third angle theorem that says this. If two angles of one triangle equal two angles of another triangle, which we have right here, then the third angles must be equal to each other. Those are the third angles. They got to be equal. If the first two are equal to these first two, then the third angles are equal. So I went through all that mess, sorry about that, just to say that angle A was equal to angle D. And I think that's it, to tell you the truth. I'm taking a peek. I think we're good with that. So let's just end it right there. All right. I hope you have a good rest of the day or night whenever you're watching this.